Hey, good morning, everybody. This is Sarah DeMeo with Acuity Solutions, and welcome to the fourth part of our 5-part webinar series, How to Expand Your Business with NX for Manufacturing. I see that some of you have joined us for all of our sessions so far, which is awesome to see. Hopefully, we've got our salespeople working with you on any questions. But for those of you who are joining us for the first time, I want to tell you a little bit more about why we put this series together. So for those of you who have already heard this, just bear with me for a minute. I will try to be brief. Okay. So I would be willing to bet that your business is encountering at least one of these scenarios. Your products are more complex today, whether in shape, structure, or size. Your lead times are getting shorter, which means your customers want their product made error-free on tight timelines, and some of them are even starting to penalize for any delays. You could be a design company who used to send your prototypes out for production, but you've decided to bring that capability back in-house. You might be doing one-off projects, some big projects, and in order for you to make a profit, you have to get the part programmed right the first time. You don't have time to, keep redoing it. And finally, it's very likely that you have multiple software systems in place that don't talk to each other, which can cause a lot of headaches and decreased efficiency. So if you're joining us today, chances are good that you are either considering the purchase of a machine with an attached Renishaw probe, or you already own one and you're tired of programming it by hand or using, workarounds and kludges to get it to work. So today, Andy's going to show you how NX on-machine probing can automate that inspection process. We're going to go a little bit into more detail to really show you how the product itself works so that you can get a feel for how you can program that part. So with no further ado, I will pass this over to Andy. Thanks, everybody.
Good morning, this is Andy Schaefers. Thank you for attending today. We're going to be showing you how to use the probing module in NX CAM to work with Renishaw probing cycles in either a FANUC or a Siemens machine tool control. Let's talk a little bit first about what we can and what we can't do with this particular application. First of all, many people sometimes think that they're going to be able to turn their machine tool into a CMM, and that's really not what on-machine probing does. When we run these Renishaw cycles, if you're not familiar with them, they're just macros that run there in the background. Is Gcode, and as a result of executing one of those cycles, you're going to be saving a probe result to one of the registers on your machine. Well, when you probe yet again, you go back and you're going to just rerun that cycle, so if you're not careful, you just keep rewriting the same register over and over again. In other words, what I'm saying is you're not really set up like a CMM that's collecting a huge number of points and keeping track of them. It's up to you as the programmer to keep track of where those go. So if you have many points, it's just not going to be really to your advantage to be using this machine in that way. So a typical use of on-machine probing would be to probe a few points on a casting that we clamp onto our machine tool and make a decision about whether there's enough material there to clean up or not, and are we going to continue. Another use might be to just probe a single point on a datum and then make a decision about whether that piece got clamped in correctly. Or a third use might be to probe a couple of points and actually modify the position of G54 based on the probe results that we got. So those are the types of probing and decisions that we're looking at in the probing module. As we cover this, then I'll look at some probing on this particular part, and then I want to go and bring up the post-processor, show you how it's linked into the probing routines and how we actually put that together in NX. Okay, so let's get started. I've got a little program begun here on the screen, and I'm showing a face milling operation just to indicate that you can intermix your probing operations with other machining type operations, and the post can handle that if it's set up correctly. So I've already got a probe here. There is a single probe that comes with NX, but of course you can make your own. So as I kind of move this out of the way, you see it's just defined as a solid body tool with a little ruby tip on it and our coordinate system. So when you look over here at the dialog box, you see there are some, it's not a standard tool. We need some additional information with probes because of the way we're approaching the part and the kind of data that we want to take. But if you start with this library part, you'll have a good example for how to set up your probes. And in a lot of cases, this one's going to work just fine for you. Okay, so now given that tool and our geometry here, let's do a little bit of probing. So create operation, and when you have probing installed, then you'll see probing as an additional type here in your operations, and then it prompts us just for a probe type tool, and we'll take our G54, our workpiece geometry here, I think. Let me double check that. Oh, yeah, I do want the G54. Okay, so when we enter the probing module, you'll see it's a dialog style where we're stacking sub-operations here in this list. So rather than begin with selecting geometry, we're probably going to want to actually go and give it a clearance plane. Place that it's going to go to before or after it finishes probing. So I'll just select inherited here. I'm sorry, plane, select the top of my part. Yeah, that's not what I wanted though. And give it an offset of a couple inches. Okay, so we're up here in the air with our clearance plane, and now when we click OK, we see that added to the list here. That's our first sub-operation. Now let's continue, and we'll add another sub-operation, and in this case let's try probing a cylinder. So we'll select a face here on our cylinder, and the arrow indicates the approach direction for the probe, so that's probably correct. It's telling us that by default it's an internal cycle, and that's also what we want. The midpoint refers to where we are in the depth of the cylinder in terms of where the probe is going to interact with the cylinder, and this is also fine. Now, if we, there's a lot of settings here. In changing these settings, you're not actually going to see much difference in the graphical toolpath. The vast majority of these settings do not affect the graphical toolpath that you see in NX. Most of them are just being output to your Gcode and are interpreted by the Renishaw macro cycle. So they're just arguments to those cycles. So let's click OK, and as we do so, then we see that we have a graphical element going down, but we don't actually see it probe that cylinder. Again, that's a function of the macro cycle in Renishaw, not the toolpath that we see in NX. Now, I mentioned that you have to be careful here when you are using these cycles, in that they will continue to overwrite the register over and over. So the next thing we might want to do is put in a user-defined event that's going to tell NX to take the result from the Renishaw cycle and save it somewhere else where we can utilize it later. So let's create another sub operation now, and I've created myself some machine control events, and one of them is called save probe results. This is obviously very simple. Let's say that Renishaw cycle is now stored in 130, and we'll say, well, let's store it out here in 181. So that adds then a machine control event. And really then that's all we would need to complete our work here. Let's click OK. Well, I'll show you real quick that if we rewind this and just animate it, I just want to show you again that there's really not much that it's going to do here, because the because of the nature of the graphical toolpath, we aren't going to see it probe that cylinder. Let's just go on here and look at the output of this program. So I've got probing 4 here inside the program, and we'll post-process that code. So here's the G-code for the face milling operation, and then you see it does in fact do a tool change, put the probe in for me, and I have made some modifications to my post so it recognizes a probe coming in, and it's going to output some code to turn that probe on, because there are a couple special things you have to do with a probe different from a regular milling or drilling cutter. Then here it's approaching the part, and at the end of that, here's the probe protected move to get back up in the air, and here is the result of that machine control event where we saved the results of 130 back to 181. Now let's continue and look at a couple of the other types of probing events that we can create in NX. So let's go back to create operation again, and we'll stay with our same geometry. Let's once again set that clearance plane, and this time we are going to, rather than probe a cylinder, we'll probe a point on the side of our part. So that'll be our next sub-operation. I'll just say point on face, and with my cursor move out onto the screen, select a point, and what you'll notice here right away, sorry, is that it comes up with the correct probing direction. And the reason for that is that the probing direction is set to inferred. Now if that doesn't work for you, you do have a choice here to use one of the machine coordinate directions to get that probing direction. Again, here's some other settings that don't affect graphical toolpath, but we can input them, and they're then output to the Renishaw macro as arguments. So at this point, we'd want to put in our machine control event, right, to save that register someplace else before we probe another point. But let's just go ahead and add another operation now. And so it's just moving back to the clearance plane and then coming back and probing that second point. Now one of the things that people notice the first time they use the probing is that although most of these dialogues here allow you to set things that you're familiar with back in milling or drilling, you cannot set the tool axis. And let's talk about how you would handle that situation now. So for instance, what if I want to probe a point on the front surface of the part? It might be hard to see over the web, but this is actually an angled surface here. So if I go back to my geometry view, you'll see that I've already set some things up. I've got a G55 coordinate system on this hole that has the z-axis pointing normal to this surface. So let's probe that now. What I need to do to probe that angled surface is be careful to select the geometry that has that MCS in it. So I'll select the G55, click OK, and now let's add a sub-operation. And now I'll just probe that point. Here's a point on the face, and so you can see then from the probe direction that it did find the correct vector. It's inferred using the G55. So here's our completed probe operation approaching from that direction. Let's take our understanding here just a little bit further, and we'll look back at this face on the part here. And I'd like to just talk for a minute about how you could integrate probing in NX with tilted working planes that several of the control manufacturers are now implementing. So as specific examples, with Siemens this would be Cycle 800, and with FANUC it's G68.2. If you're not familiar with a tilted working plane, it's much more advanced than just a typical G68, where on a surface like this I could create a coordinate system. I'll just make one as an example here. And rather than being able to set only the z-axis, with a tilted working plane you can actually set the x-axis as well. What this means then is that you're not limited to the kinematics of your machine tool. In other words, you're probably familiar with a table-table situation where you rotate to that compound plane, and of course you have no control of how the x-axis is going to be pointing, and so you're just then forced to deal with the situations that arise from the orientation that you're given. With a tilted working plane, you actually get to select the orientation or the angle of how that XY plane is going to appear here. So we could use this tilted working plane, and if we wanted to then probe this face, knowing that the nominals are always going to be Y0. And if you think about that, that can potentially be, the inability to take care of that is potentially a problem with probing on an angled face, because someone's going to have to interpret and do the trigonometry on those probe points before they can be interpreted. With a tilted working plane, you orient towards the face that you're nominally probing, and then you know everything's going to come out 0 if your part was perfect. Okay, let's go from here and look at how you're actually going to set probing up so you can execute it in your post-processor environment. I'm going to bring up Post Builder here, and I've got a milling post open right now, and if we go and look at NC data definitions and then other data elements, what you see is that I've checked the box for inherit UDE from a post, and then I've grabbed probing cycles FANUC. Now I think people sometimes get confused about these probing cycles that are out there. It says probing they'll say probing cycle Siemens and probing cycles FANUC, and these do not refer to a FANUC probe. Both of those files are for the Renishaw probe. Those are the macros that they support. It's just the control that you're using that determines which of these files that you select. So in fact, at this point, the only probe that we support through NX are the Renishaw probes. When we then inherit this UDE, we're getting only the event handlers coming across from this other post, not the logic from the post. We'll go look at the probing cycles here in a minute, but sometimes people want to go in and source the TCL file and put the probing file here. This really doesn't work well, because this is going to cause it to suck up all of the logic from that other post, and then you're going to start getting some really strange behavior. So make sure that you're just inheriting the UDE here at this point. So now let's close this post, and we're going to go look at the probing cycles themselves. So this is the probing cycles post that comes with NX, and it's automatically loaded. You don't have to load it yourself. It's just there in the post processor directory. If we look through this, again, there's just nothing really here for the logic of the post, because this one is only used to inherit those UDEs. If we go to the custom commands, we do see a couple of things here that relate to probing, to set up the axis, and a couple of other things. So where do those get executed? Well, if we go back to the machine controls side of things. So I'm here in toolpath machine control, and we pull the bar down. This is where the actual guts of this probing post is. We've added these additional event handlers. For instance, if we get for this post, if we get a command or an event to turn the probe on, here's what we're going to get as an output: G65, P9832, and then a G5.1. So if you need to modify that, of course, you're going to be going into the probe post and taking care of that here. One of the real typical changes that people need to make to their probe posts involve the G65 that you see here. These are set up so that G65 is modal on your FANUC control. What that means, of course, then is that if the next line out is a G65, you're not actually going to see the G65 executed. It just goes right to the P981. But many controls are not set up. They need to see the G65 come out every time. So you're going to be coming here, right-clicking, and forcing output on that G65. If you just go through all of your events here, you can handle that pretty quickly. And I should have pointed out then that we looked at those custom commands earlier. Those are just executed here. If I edit, you'll see one of them. It's just setting up that axis for the inferred direction of that probe. So I think you'll find then, with a quick addition to your milling post and maybe forcing the output on these G65s, that you're going to be in business pretty quickly to get some probe output going. What you may find missing are for instance, it's not going to automatically turn your probe on because this event is not executed. You're going to need to do one of two things. You're either going to need to modify your post so that when it sees that there's a probe tool in the spindle, it's going to execute this event to turn the probe on. The second thing you can do is just add a UDE manually. And that UDE is just going to be an event that says probe on. You don't need any arguments, just execute it, and it will see this and turn the probe on for you. So there's a few things like that that just need to be customized for the way you want to handle probing events at your company. Of course, if you just want to get this going and you don't have a lot of expertise with Post Builder, here at Acuity we're happy to help you do that. Okay, at this point I want to turn it over for questions and see if you guys have any additional information that you need. So I'm going to try and unmute the lines, and this can be problematic if there's a lot of background noise when we start getting feedback, but let's see how it goes here. Okay, I think I've got everyone unmuted. Are there any questions about the NX probing at this time?
Okay, so it doesn't look like we have any questions, so thank you, Andy. I think that was very informative. Just want to leave everybody with a quick review. Our fifth and final session of this series is coming up on April 29th, where we will show you the NX-CMM process for programming your coordinate measuring machines within NX using the data from your 3D model. And finally, our contact information here on the screen. We've got our phone, 888-747-0850. Our sales team, you can reach Sarah Majors at sarah@acuityinc.com or Paul Stevens at paul@acuityinc.com. Our website here, acuityinc.com. And finally, I'd like to introduce you to our new blog, which we just launched a couple months ago, and you can visit it there, acuityinc.com/blog. So thanks everybody for joining us. If you have any questions, don't hesitate to let us know. See you next time.